Hello friends, this session is for inequations questions where this range of -1 to +1 becomes important. Some interesting observations to begin with. 1 upon x. So intuitively when we think that a number like let's say 2, when we take the reciprocal of this 1 upon 2, the value reduces. 2 becomes 0.5. However, this range of -1 to 1 is very important. Here the numbers behave differently. So for example, imagine a 0.5. 0.5 is one number, but when we take the reciprocal of it, it becomes 2. So the reciprocal is not smaller than the original number, it is bigger than the original number. Similarly, in case of negative numbers, we think that if it is -2, then 1 upon -2 should become a small negative number. Okay, it becomes negative 0.5 and therefore the value is less negative, therefore more than the original value. However, again look at this range. In this range, think of a negative number. Let's take a negative 0.2. So negative 0.2, take the reciprocal of it and now it suddenly becomes a big negative number, negative 5. Right? This range behaves very differently. That is why I have chosen to have this different session on this particular range. A lot of GMAT questions are based on this range. If you don't consider the peculiar behavior of this range, a lot of questions go wrong. Similarly, now let's take the case of square of a number. So we think if 3 is a number, when we square it, it becomes greater, it becomes 9. Fair enough. However, think of a number in this range. Think of a number such as 0.3 square. What happens? Although you are squaring it, it is not increasing, it is reducing. 0.3 square is 0.09. So you have to be open to these possibilities, especially in the DS questions when you look at inequations. Look at this similarly, x cube. One may think that when you are cubing something, you are making it bigger. 2 cube is a much bigger number. However, think of a number such as 0.2 cube. This is 0.008, a much smaller number. So similarly, if it is a negative number, -2 cube would be a big negative number. However, minus 0.2 cube would be this time a smaller negative number, 0.008. Square root x. So when we think that we are taking square root of something, we are reducing it. Square root of 9 is 3. Think that it should reduce. However, think of a square root of a small fraction, square root of 0.5. See, the value is not smaller than 0.5. This will be approximately 0.7. So when you take square root of a number that is in the range of 0 and 1, then the square root gives you a bigger value. All these observations are very important on the inequations questions on the GMAT. And now let's apply these concepts by some live examples. A warm-up question to begin with, quite straightforward. If x square is less than x, what is the range of possible values for x? So if you have seen my earlier video on the concept of mod-based inequations questions, I have explained, rather the factorization-based inequations questions, I have explained this in detail. First bring all the variables on one side, then factorize. X minus 1 is less than 0. Equate each term to 0. You have one node x is equal to 0, the other node is when x is equal to 1. Rightmost range is always positive and then alternate negative positive, and therefore you have a value 0, a range of 0 to 1 for this inequation to hold true. However, if you were to do it intuitively also, imagine x square is less than x. So negative values are all gone. X cannot be negative, because if it were negative, x square becomes positive, and a positive value would always be greater than and not smaller than a negative value. So it has to be a positive value. However, if it were a big positive value, for example, let's say 2, then 2 square would always be something even bigger. So if square of a number is smaller than the original number, that means it is a small positive value, right? And therefore, otherwise also you could have got the correct answer E here. That's a fairly easy question. The difficulty level will increase as we proceed with this video. One more warm-up question. If x is positive, which of the following may be true? So for these questions, understand the approach must be may be true. So we need only one case when a statement is working fine. So for each of these, we try to get just one example where the statement is true. So to begin with, we see that x is greater than x square. When is that possible? We just saw when x is a small positive number. So for example, 0.5, So 0.5 square will be 0.25. 0.25 x is zero point 0.5 and 1 plus x is 1.5. So this definitely works in x is equal to 0.5. The students often ask me that how do I come up with these examples where they are working? So the answer is that look at some part of this inequation and try to think of a value where it works. So this part becomes important. If x is greater than x square, imagine if x were a big positive number, then this won't be true. Negative, of course, this won't be true. So it has to be a small positive number. That is how you intuitively come up with examples where such inequalities hold. Right, so this works definitely in this case. One should hold. Look at the second one. Try doing it yourself. So in this case, again look at this part. It gives you that x is less than 1. If you take x this side, it becomes x is less than 1. If x is less than 1, for example, if x is, let's say, minus 2, so 2x becomes minus 4, 1 plus x becomes minus 3, and x square becomes positive 4, right? This is when x is equal to minus 2. So yes, this is also holding true for such a case, and therefore this is also working. This worked, this worked. Once again, see how I do it is take one part into consideration which gives you some hint, and then using that try to prove the statement correct. If there's some discrepancy, you won't be able to prove it correct. Now similarly, let's try this one. 2x is less than 1 plus x. So once again, it gives x is less than 1. Now, if we of course take this value of minus 2 here, this is not going to be the greatest. We have to help this statement in being correct because the question is asking maybe. So minus 2 won't be a good example. We want a value where 1 upon x ends up being a great value, a bigger value. And therefore, again, this range of minus 1 to 1 becomes important. Let's take a value such as 0.5. What would happen? 0.5, this will become greater, this will become 2. However, we have to take a value where 1 plus x is greater than 2x. So something like 0.5 is helping that as well. 2x becomes 1. We're taking 0.5 value, remember. 1 plus x, so this becomes 1.5. And 1 upon x means 1 upon 0.5, this becomes 2. So this is also working fine. So 1 worked, 2 worked, 3 worked, all of them worked. The correct answer is option E. Now imagine if we had not taken this case of 0.5 separately, then probably this statement may not have sounded correct. And this is a mistake that a lot of students would commit, that while taking examples, intuitively we don't take fractions. That is a shortcoming in our approach generally, that we don't assume a fraction, for example. How often do we think that x can be a 0.2 or negative 0.5 or positive 0.1. When we take examples, we take integers, and generally that they're two positive integers. So, and that is where GMAT plays on your psyche. It gives you these questions where this range becomes very important, So the answer here is option E. Let's look at the next question. This was a slightly more difficult question. Let's delve deeper and solve a few more questions here. Please try doing it yourself. Now in this question, where the question is asking something is always correct, we have to prove each option incorrect. Okay, so we have to defy each option. When we are not able to do it, to defy an option or prove it incorrect, that means that option is correct. So very clearly I am trying to prove each option incorrect here. 1 upon x is greater than x. When is that possible? It's possible when x is a small positive number, a small fraction such as 0.2, 1 upon x would be 5, which would be of course greater than zero point 0.2, or this is possible when x is a big negative number, for example minus 5. So 1 upon 5 will be a small negative number which would be greater than a big negative number. So these are the two cases. X is greater than x square. So zero point 0.2 is greater than 0.2 square. Yeah, here it works. But minus 5 is not greater than minus 5 square. Here it doesn't work, and therefore option A is not always correct. Look at option B. If x is greater than 1 upon x, so when is this possible? This is of course possible in two cases. This is possible when x is a big positive number, let us say 5, or when x is a small negative number. This is a case which most of the students will miss, negative 0.2. See, x negative 0.2 would be greater than 1 upon negative 0.2, which would be negative 5. 2x is greater than x. So yeah, when you don't take this case, you will think that this is the correct answer choice. This is a trap that I want to explain through this video, that unless you are very careful about this range, you will keep on missing such cases, and such options will keep making sense to you. This is not the correct answer choice, because this works in this case, but in this case this doesn't work, and B is not the right answer choice. I'm sorry, B is not the right answer choice. And let's look at option C here. X is greater than 2x. This is possible only when x is negative. Okay, so x is greater than 2x, but again there are two possible cases. Remember, there is a 1 upon x here, so we must take two examples. One example should be of a big negative number, say minus 5, and the other should be of a small negative number, a fraction, such as in say negative 0.2. So 1 upon x is greater than x. So yeah, 1 upon negative 5 will be greater than negative 5. So this is true in this case. However, this would not be true in this case. See, 1 upon x would be a big negative number, and it won't be greater than negative 0.2. So this can also be eliminated. Remember again, such values are playing the role in eliminating answer choices. Option D, x square is greater than x. So this is possible in two cases. One case when x is a big positive number, let's say 5, and it is also true when x is negative. Negative, it can be a negative small integer, negative big value, negative small value. So I'm dividing this deliberately into three types. Yeah, x cube is greater than x square. So this becomes 25. 125 will be greater than 25. However, in these two cases, both of these cases, x cube would be something negative while x square will be something positive, and therefore this is not correct. So this should be easily eliminated. Look at the last one. This better be correct. We have eliminated 4 choices now. If x is greater than 1 by x, so this part is same as this part. So we took these two examples here, 0.2 and negative 5, where x is greater than 1 by x. One case when x is a small positive fraction, and the other when x is a big negative value. X square is greater than 1 by x. I'm sorry, this was corresponding to option A. This is option B. So these are the two values which worked. So one case when x is a big positive number, so 5 is greater than 1 upon 5, and the other is when x is a small negative fraction. So negative 0.2 is of course greater than negative 1 upon 0.2, which would be negative 5. So these are two cases. X square is greater than 1 upon x. 1 upon x in this case would be 1 upon 5, which is 0.2. In this case it would be 1 upon negative 0.2, which would be negative 5. X square would be in this case 25, which is of course greater than 0.2. So here it is working. The second case also, x square would be negative of 0.2 square, which would be a positive value, however small. And this will of course be greater than this big negative number. So this is a case which is working in both type of examples, and therefore E is the right answer choice here. This is probably the most difficult you can see on the GMAT. If you could solve this one, you really understand the concept of inequations when it comes to this range of -1 to +1. Let's practice a bit more. Try solving it yourself. So which of the following can never be correct? In these cases, try to have one case where it is correct. And when you get such a case, you can eliminate that answer choice. That is the right way of approaching these questions. So let's try proving each of these correct and then eliminate if we are able to prove one correct. So we want 1 minus x to be the greatest here. When is that possible? That is possible when x is a negative value. So 1 minus something negative will make it something positive. However, remember, we don't want x to become a very big number, otherwise x square will become a very big number, okay? And it will become greater than 1 minus x. So the right example to take would be the example of a small negative value. However, we should not take a value which is between 0 and -1, otherwise it may just get complicated. X square becomes smaller in magnitude. However, in this case, this won't actually matter. We can simply take the example of, let's say, a let's say -1. Okay, and -1, x is -1, x square becomes 1, and 1 minus -1 will be 2. So the trick in this question was to take a small negative value. So if you had taken a -0.5 also, this would have worked. This would have been a -0.5, this would have been 0.25, and this would have been 1.5. However, if you had taken the example of a -3, this statement may have sounded not correct, because -3 square, this becomes a big number. So this can be true, and therefore this statement 1 should be eliminated. Look at number 2 here. X is less than x square. So when is this possible? This is possible when x is, of course, something negative, or it is possible when x is a big positive value. Okay, it's always good to take examples. Let's say a -2, and another example can be a +5. Okay, however, for this part to be true, x square is less than 1 upon x. Of course, the negative case has to be eliminated, and x square is less than 1 upon x. Treat this separately. When do you think this is possible, that the reciprocal becomes greater than square? This is possible when x is a small positive number. That's the only possible case. For example, if x is 0.5, 1 upon 0.5 becomes 2, and 0.5 square is a small fraction. In such cases, this is possible. Okay. However, in such cases, 0.5, you will see that this part is not possible. X square will become a smaller number than x. Okay, so this is not possible. And if we take this case 5, the kind of value that satisfies the first inequality here, then in such a case 1 upon x becomes a small fraction which will never be greater than x square, the square of such a big number. And therefore this is something which can never be true, and the question is asking which can never be true. Therefore this is a fine statement. Let's try proving statement 3 correct. We want x square to be the greatest, 1 upon x to be in the second greatest, and then x itself to be the smallest. And easily, if you imagine some big negative number, for example -2, this is a big negative number. 1 upon -2 will become a small negative number, and square of it will become something positive. So of course this is possible. Therefore this should be eliminated. So the correct answer here is 2 only. Look at one more question here. In what cases will x be greater than x cube? I think two kind of cases. When x is a big negative number, such as say a -2. See, -2 cube will become a big negative number, which would be smaller than a smaller negative number, -2 itself. Or when x is a small positive number, small positive fraction, such as a 0.5. 0.5 cube will become a much smaller positive value. So these are the two kind of cases when this is possible. Okay, so yeah. And now let's look at statement 1 alone. When we look at statement 1 alone, x square is less than 1. This would also be true for values such as a negative zero point 0.5. See, for values such as negative zero point 0.5, zero point 0.5 square will be 0.25, which is less than 1. However, in this case, put it here, negative zero point 0.5 cube will become a much smaller negative value, and therefore on negative zero point 0.5 we will get a value such as, we'll get no as an answer. However, if you put a positive 0.5, positive 0.5 is also satisfying this inequality. However, if you put it here, we will get on 0.5, we will get yes as an answer. Okay, so no is also possible, yes is also possible. Statement 1 is not sufficient. Look at statement 2 alone. Again, try proving it insufficient. Again, the same two examples can be taken. X cube is greater than minus 1. So on a negative 0.5, you will see something negative, small negative value, which is greater than minus 1. We will get no as an answer. We can take a small positive value on which you will get yes as an answer. So again, no and yes both are possible. Not sufficient. Combining also, we just saw that the same examples are working in both the cases. Therefore, combining is not going to add any value. Even on combining, this is not going to be sufficient. And therefore, the answer is going to be option E. So a very important concept, guys. This range of -1 to 1 is of great interest to GMAT. Whenever you take examples, try to take examples in this -1 to 1 as well. Don't ignore this range, because this range behaves quite differently from other bigger negative or positive numbers. The reason for preparing this video is to explain how this range behaves differently, and therefore the need for being aware of the exceptions this range brings, and taking examples of these values as well while solving these questions. I hope this helps. Thanks a lot for watching.